All right, now we're going to be writing an equation with irrational or imaginary roots. So this is a little different, but one thing that you already remember about roots is that they can be rational or irrational. You know, that's a possibility. You know that if they're rational, it's like 7 or a half. Anything can be written as a fraction or as a whole number. You know, anything can be written as a fraction, right? Or a whole number. And then irrational is anything with a radical still left in it. So irrational would be, let's just say, would be radical 7. But remember, whenever we put the square root on to solve these equations, we will get a plus or a minus. Another example would be 2 plus or minus radical 3. These are examples of irrational roots. They can be equal or unequal. We have, for example, if we say 2 with a multiplicity of 3, that means we have 3 roots and they're all 2, so they're all the same. That would be equal. Unequal is just everything else. The degree of equations, the degree of an equation determines the number of roots you will have. So for example, if I have like x to the 4th minus 3x squared plus 7, the degree is 4, so there's going to be 4 roots. Some of them will be rational, irrational, equal, and some of them will be imaginary. So imaginary and irrational roots, so the ones with the radicals, and remember imaginary are ones with i's, those always travel in conjugate pairs. That's what the plus or minus thing is. So if we have radical 5, if I say radical 5 is a root, then I know positive and negative radical 5 were roots. So radical 5 and negative radical 5 were 2 roots. So if I say negative 2 plus 3i, say if that's one of the roots, then you know that negative 2 minus 3i is another. Remember, conjugate pairs means the middle sign changes. Okay, the middle sign changes. That also means, this, you can't really tell that that's a middle sign. However, it is. Okay, so the thing in front of the radical or the I is also be positive or negative. Okay, so to do this, it's actually a little easier than yesterday. Your standard form for a quadratic equation is ax squared plus bx plus c. We all know this. When you write an equation, the sum and the product of the roots can help you write the equation. So what that means is, if I know that what the sum of the roots is, so if I say, let's work down here. Okay, we'll do this example as we go. The sum of these roots, 5 and negative 2, 5 plus negative 2, we get 3. So this is the sum of the roots. The product of the roots is 5 times negative 2, which would be negative 10. That's just the sum and the product of the roots. To write this equation, we can just straight up write the equation without even multiplying. A equals 1, B equals the opposite of the sum. So negative the sum up here means the sum is 3, so B is going to be negative 3, and the product is just straight up the product. So negative 10 is negative 10. So this equation would be y equals x squared minus 3x minus 10. So just to prove that, you remember that if we have factors, so if x equals 5 is a root, then x minus 5 is a factor. And similarly with x equals negative 2. If I were to multiply this out, x minus 5, x plus 2. You can see why this is happening. So we're changing the signs when we do this. So when you multiply, you get negative 5x and positive 2x. So then when we add them, we get negative 3x, which is the same as here. And then the product is always going to be the same, because if the signs are the same, going to have positive, and if the signs are different, the signs are going to be negative. So This is a somewhat simpler way to do it. You can choose to do it either way when you have rational roots, but what's going to happen is it's almost impossible to do this our way that we did yesterday with irrational or imaginary roots. So this makes life easier when the roots are 3 minus 2i and 3 plus 2i. So if I know 3 minus 2i is a root, then I know 3 plus 2i is its conjugate pair. Radical 7 is a root, then negative radical 7 is also a root. So we can do the sum and the product with these and write our equations without having to do some crazy multiplications. So let's just show you how this works. So let's just do this one. This was 3 minus 2i, so 3 plus 2i is the missing root. So all we have to really do is find the sum. Adding these up, this is nice. These guys just cancel right out, and we're just left with 6. Sum is the easiest thing to find. Product, it's nice to just do it in your calculator because it does work out nice in your calculator. Conjugate pairs always cancel out their imaginary part or their irrational part. So 9, this is negative 6i, this is positive 6i, and this is negative 4i squared. So these cancel themselves out. We're left with 9 minus 4i squared. But remember, I squared is negative 1. So this is 9 minus 4 times negative 1, or 9 plus 4, which is 13. So we have the sum and the product here, and now we just have to write the equation. Okay, so A equals 1, always. Straight up, just 1. B equals the opposite of the sum. So the sum is 6, so B is going to be negative 6. And then the product is just your C. So the equation is x squared minus 6x plus 13. And remember to always put your y equals or f of x equals there. All right, so let's just try it with this as a quick example. First, I'm going to list the missing roots. So sorry, it changes the size. I don't know why. So negative 2 plus radical 5 is the missing root. So these two are conjugate pairs. Negative radical 7 goes with positive radical 7. That's a conjugate pair, and 0 is just 0. So the only time we do the conjugate pair thing is when we have rational, when we have irrational or imaginary roots. So for these two, I'm going to do these two first. This is my first one. So this is number 1. So the sum is where the negative radical 5 and positive radical 5s go away, so I'm left with negative 4. The product, you can multiply those out, but the product is simply negative 1. Yep, and then we just write it. So I'm not going to go over how to multiply them. So A equals 1, B equals the opposite of negative 4, which is 4, and C is the same. So this one is x squared plus 4x minus 1. So that is the quadratic equation that came up with negative 2 plus and minus radical 5. So doing radical 7 and negative radical 7, so this is the second thing I'll do. And then I'm going to multiply them together. So we still have to multiply, sorry. The sum, we add those two together, we just get 0. The product is negative 7. Okay, and now we just write this in. So A is 1, B is 0, C is negative 7. So it's just x squared. We don't write the B because it's 0. This is the second piece. And we all know that if we have 0, then it's just x. X is your factor. So what we are going to have to multiply together is x squared plus 4x minus 1, x squared minus 7, and then at the end we can just multiply it times x. So this is just a nice multiplication. I am going to pause this for a second and do the multiplication, and then you can check your work. Okay, so the final, well, when you multiply these two together, you get this. So x squared times x squared, you're going to have a highest degree of 4. And then this one has a final degree of x to the 5th, so that the degree is 5. So I have 2 roots here, 2 roots here and 1 root here, equaling a total of 5 roots. So my answer should have, the highest degree should be x to the 5th. All right, have a wonderful day.